Or should I say, Big Bang? The Big Bang. Ahem. So after the Big Bang, the universe resembled a hot soup of protons, neutrons, and electrons. After it started to cool down, the protons and neutrons began to combine, first forming ionized atoms of hydrogen and later some helium. These ionized atoms of helium and hydrogen attracted electrons, turning them into neutral atoms. As a result, the light was able to travel freely for the first time ever, since it was no longer scattering off free electrons. What does it mean? The universe was no longer dark. At the same time, it was still about a few 100 million years after the Big Bang before the very first sources of light started to appear. That's when the cosmic dark ages came to an end. We don't know for sure what this universe's first light looked like or how the first stars formed. Luckily, we have the James Webb Space Telescope to help us find the answers. How come? All because this is an infrared telescope. Why is it important? Let's figure it out. Imagine a star. It's a very, very old star, maybe the first star out there. Light leaves this star 13.6 billion years ago and settles off on an incredible journey through space and time. It needs to get to our telescopes. By the time this light reaches us, its color or wavelength shifts towards red. That's something we call a redshift. It happens because when we talk about very distant objects, Einstein's theory of general relativity comes into play. According to it, the expansion of the universe also means that the space between objects stretches, making them move away from one another. But that's not all. Light stretches too, which shifts it to longer wavelengths. Eventually, this light reaches us as infrared. In other words, redshift means that light that is originally emitted by the first stars or galaxies as ultraviolet or visible light gets shifted to redder wavelengths by the time we catch a glimpse of it here and now. For the farthest objects with very high redshift, that bare minimum of visible light is shifted into the near and mid-infrared part of the electromagnetic spectrum. That's why to see those space objects, we need a super powerful telescope. And if we talk about the Webb telescope, it can see back to about 100 million to 250 million years after the Big Bang, which is incredibly awesome. So by observing the universe at infrared wavelength, James Webb lets us see things no other telescope has ever shown before. The primary goal of this incredible piece of equipment is to study the formation of galaxies and stars that formed in the early universe. To look that far back in time, we need to look deeper into space. All because it takes light time to travel back from there to us. So the farther we look, the further we glimpse back in time. To find the first galaxies, James Webb is going to make an ultra-deep near-infrared survey of the universe. Then it'll follow it up with a few other methods of research. Now, as you remember, the gas between stars and galaxies in the early universe was opaque, and energetic starlight couldn't penetrate it. But then, about 1 billion years after the Big Bang, it suddenly became completely transparent. Why? The James Webb Telescope might have found the reason. At one point in the past, the first galaxy's stars emitted enough light to ionize and heat the gas around them. This helped clear the view over hundreds of millions of years. The newest insights scientists got were about a time period called the era of reionization. That's when the universe underwent some dramatic changes. After the Big Bang, gas in the universe was unbelievably hot and dense. Hundreds of millions of years passed, and it cooled down. But then, something baffling happened. It was as if the universe hit the repeat button, and the gas became ionized and hot once again. It could have happened because of the formation of early stars. After that, millions of years later, this concoction became transparent. For a long time, researchers have been hoping to find definite evidence that could explain these changes. And now, the telescope has finally shown that those transparent regions are located around galaxies. Astronomers have seen these galaxies reionize the gas surrounding them. Even better, they've managed to measure how large these transparent regions are. They're ginormous compared to the galaxies themselves. Imagine a hot air balloon, and now imagine a pea floating inside. You've got it, and guess what? These tiny galaxies drove the entire reionization process, clearing huge regions of space around them. These transparent bubbles kept growing until they merged and caused the entire universe to become transparent. The research team chose to target a period of time before the end of the era of reionization. At that time, the universe was not quite opaque, but not quite clear either. It was a patchwork of regions of gas in different states. To find out this cool fact, the astronomers aimed the James Webb Telescope in the direction of a quasar, an incredibly bright space object. It acted as a giant flashlight, traveling towards us through different regions of gas. It was either absorbed by the patches of near opaque or moved freely through the areas where the gas was transparent. The scientists then used Webb to examine galaxies in that region of space. They found out that these galaxies were usually surrounded by transparent regions with a radius of about 2 million light-years. For comparison, the area the galaxies cleared was almost the same distance as the space between our home Milky Way galaxy and our nearest neighbor, the Andromeda Galaxy. And the telescope witnessed those galaxies in the process of clearing the space around them. It was the end of the era of reionization. Until then, no one had evidence of what caused reionization. The team is planning to dive into research about other galaxies in 5 additional fields. The Webb telescope's results from the first field have been overwhelmingly clear. And even though the astronomers had expected to identify a few dozen galaxies existing during the era of reionization, they actually managed to spot 117. Now, let's talk a bit about the main hero of today's show, the James Webb Space Telescope. It's an absolutely stunning piece of equipment which is around 100 times more powerful than the Hubble Space Telescope. And the latter has observed places that are 13.4 billion light-years away. The James Webb Telescope is also on the pricey side, to put it mildly. Even though originally the cost of the telescope was estimated to be just $1 to $3.5 billion. The whole development process cost around $10 billion. For comparison, it cost NASA $4.7 billion to build and launch the Hubble telescope, and it was another $1.1 billion to fix it in orbit. Even though the James Webb Telescope itself is 3 stories high and the size of a tennis court, its mirrors are the lightest large telescope mirrors of all time. During the manufacturing process, they underwent a 92% reduction in weight. When you look at them, the telescope's mirrors seem to be gold, but in reality, they're made of beryllium. This is a steel gray, lightweight, and brittle metal. A gold coating is applied to each mirror, that's true, but they can't be produced entirely out of gold, since this precious metal tends to expand and contract, even with small temperature changes. So the total amount of gold in the James Webb Space Telescope is less than 2 ounces. That's a golf ball-sized piece of gold. And the gold plates covering the mirror are less than 1,000 atoms thick. As for the telescope's abilities, it would be able to clearly see a US penny from 24 miles away and a football from 340 miles away. James Webb's telescope side is cooling itself down, and its temperature doesn't rise higher than minus 370 degrees Fahrenheit. That's cool enough to make liquid nitrogen. A truly enormous 5-layered sunshield surrounds the telescope and reflects away as much sunlight as possible, letting the telescope stay cool.
It's been more than a year since the James Webb Telescope, which had taken over 20 years to complete, was launched. And for such a relatively short time, the ultra-modern and most powerful in history piece of equipment has already made plenty of discoveries. By observing the universe at infrared wavelength, James Webb lets us see things no other telescope has ever shown before. The primary goal of this incredible piece of equipment is to study the formation of galaxies and stars that appeared in the early universe. For example, look at the closest to us stellar nursery, a region of space where new stars get born. NASA has shared an image from James Webb that shows a small star-forming region. If you look at the picture attentively, you'll see jets bursting from infant stars. Around them, different colored clouds of cosmic dust are colliding with one another. The view is mesmerizing. The red dust consists of molecular hydrogen. You can also notice that some stars have something like shadows. Those hint at the creation of what will later become planets. At first sight, the image may seem chaotic, but astronomers claim that it's a relatively small and quiet stellar nursery in comparison to some others. Many young stars there are similar in size to our Sun, or a bit smaller. The photo itself was taken with the help of Webb's near-infrared camera, NIRCam. It's the observatory's primary camera that snaps images of the cosmos in 2 different infrared ranges. Another amazing discovery the Webb telescope has made is smoke molecules in a distant galaxy. It's the first time such molecules have been discovered so far away from our planet. The galaxy in question lies 12.3 billion light-years away from Earth. It most likely formed about 1.5 billion years after the Big Bang. Despite such a huge distance between the galaxy and our planet, scientists have managed to detect chemical compounds found in soot or smoke, and it's quite a big deal since it has pushed the record for detecting similar complex molecules back by around 1 billion years. This study has also confirmed the sheer power of the coolest piece of space equipment of all time. It managed to make this discovery despite the fact that the spectrometer needed for the measurements didn't perform to the fullest after having experienced a sudden and surprising degradation. The James Webb Telescope has also helped to boost our understanding of exoplanets. Those are planets orbiting stars other than our own Sun. At the beginning of 2023, the observatory spotted its first exoplanet, LHS 475b. It's located 41 light-years away from Earth and is approximately the same size as our planet. According to NASA, nowadays, James Webb is the only operating telescope capable of categorizing the atmosphere of Earth-sized exoplanets. The research team behind the discovery believes such results underline the precision of the telescope. They hope that it will help us locate many more rocky exoplanets that we might be able to colonize in the future. Even though, at first sight, it may seem that the universe is pretty empty, it's actually a very busy place. And Webb has all the necessary instruments to see all kinds of cosmic events happening out there. Just look at this image of WR-124. It's a star on the cusp of its explosive demise. In the image, the star is about to go supernova. It happens when a star runs out of its fuel and explodes at the end of its life cycle, releasing a giant cloud of space dust and hot gas into space. The star captured by the Webb telescope was at the Wolf-Rayet stage of its life. That's a period when a star is shedding its outer layers before going supernova. The next amazing thing discovered by James Webb is a star-planet hybrid with very strange clouds. This bizarre world, VHS 1256b, is actually a brown dwarf. Those are bigger than planets but too small to classify as stars. They emit some light of their own and are quite hot, but their mass is simply not enough to fuse hydrogen into helium like full-fledged stars do. Space bodies of this kind aren't actually brown. They occur in a wide variety of colors, but those are mostly invisible to the human eye. What we can see is the light they emit, and to us, it appears to be dark orange or magenta. The brown dwarf discovered by the Webb telescope is almost 20 times the size of Jupiter. It orbits 2 red dwarf stars, and to complete one orbit, it needs over 10,000 years. Astronomers first found out about this unusual exoplanet in 2016, but at that time, they didn't classify it as a brown dwarf, and, thus, couldn't explain its puzzling reddish glow. Now, thanks to the James Webb telescope, they know the space object's origin. Anyway, back to those clouds. As you know, clouds on Earth are made of water vapor, but those on the brown dwarf are different. They seem to be made of sand. It looks like good old sand from Earth, but it's actually not. The clouds are made of tiny particles of silicate. Another recent discovery involves several large galaxies that scientists believe were born not long after the Big Bang. They aren't supposed to be there, and no one expected to find them. But the James Webb Space Telescope has spotted them. These galaxies, as massive as our home Milky Way, are full of mature red stars. Astronomers have analyzed the light coming from them and estimated their age 500 to 700 million years after the Big Bang. It means that they came into being when our universe was very young, almost a baby. But the most bizarre thing about these galaxies is their tremendous size and the age of the stars dwelling there. The data received by the telescope don't coincide with the existing ideas about what the universe looked like and how it evolved in its early years. It also doesn't match the earlier observations made by Hubble. And here, James Webb has captured a distant region of space in unprecedented detail. This section of space is known as Pandora's cluster. In the image, you can see 3 massive clusters of galaxies coming together and forming a megacluster. The combined mass of these clusters acts as a powerful gravitational lens. And thanks to this natural magnification effect, scientists can see other galaxies in the region. Astronomers claim that the most recent image of Pandora's cluster is stronger and deeper than they have ever seen. James Webb has also managed to spot thousands of young stars never seen before in the Tarantula Nebula. This space formation got its nickname because of the appearance of dusty filaments spotted in previous images. It's the biggest star-forming region in the local group, which includes the galaxies nearest to the Milky Way. The Webb telescope's images have helped to shed light on the composition of the Tarantula Nebula. The telescope has also detected protostars, infant stars in the process of gaining mass. Astronomers expect that these protostars will eventually form and shape the nebula further. Among other discoveries made by the James Webb Telescope, you can see the birth of 50 distant stars. Some of them power protoplanetary disks, which might later form solar systems light years away from our own. Here's one more image from James Webb. You can see a supermassive black hole that has a mass of 9 billion suns. It's so ginormous and ancient that scientists are struggling to explain its existence. Astronomers have also discovered a distant ring of dust, rock, and gas that contains a chemical called methylcation. It's known as a molecular building block of life, and it makes most of the organic material on our planet. James Webb helped researchers see powerful sandstorms on a planet 235 trillion miles away. Astronomers were happy to discover this treasure chest of countless tiny sand particles. Now look at this. Do you recognize this image? Those are the so-called pillars of creation. But this new view shows us just how star-speckled that dusty region actually is. You can compare the new photo with the one taken by Hubble in 2014. This is astonishing proof of scientific progress.
The James Webb Telescope, or JWST, is like the ultimate intergalactic paparazzi. It takes pictures of some of the most famous celebrities in the universe. Stars, galaxies, exoplanets, you name it. The James Webb Space Telescope will snap a photo. So if you're a fan of cosmic celebrities, let's take a look at some of these best star-studded photos. The Carina Nebula. The image of the nebula with the beautiful name Carina was published on July 12th. JWST captured a beautiful view of the nebula, located about 7,500 light-years from Earth. Nicknamed the Cosmic Cliffs, it is, in fact, a hotbed of young stars, some of which are several times larger than our Sun. The Carina Nebula is a celestial spectacle located in the southern constellation Carina. It's really huge, approximately 260 light-years across. Massive stars within this nebula are so bright and hot that they create a glowing cloud of gas and dust around them. The Carina Nebula also contains swirling clouds of gas and dust where new stars are being born. The gas collapses under its own weight, becomes hotter and denser, and all this eventually leads to the creation of new stars. However, the Carina Nebula isn't just some peaceful place of star formation. It's the site of some of the most destructive events in the universe, which create massive shockwaves that obliterate everything in their path. Very chaotic and cool. The Stefan's Quintet. This photo was also posted on July 12th. Stefan's Quintet is a visual group of 5 galaxies located at a huge distance from us, about 290 million light-years in the constellation of Pegasus. It's like a cosmic family reunion. All these galaxies are related to each other and interact with each other in some interesting ways. They're pulling and tugging on each other with their gravity, constantly exchanging gas and dust. This interaction is causing some of the galaxies to collide and merge, which can create all sorts of cool effects, like bursts of star formation and supernovae. Thanks to JWST, we were able to see shockwaves, tidal tails, and other amazing details about these galaxies. Their interactions create a stunning sight that we can see in this photo. Jupiter. And here's our old giant friend. This image was published by NASA on August 22nd. Jupiter is the largest planet in our solar system, and it's known for its many moons and its beautiful swirling clouds. But it also has a system of rings, just like Saturn, which are made up of tiny particles of dust that orbit the planet. These rings are much smaller and less visible than Saturn's, but they're still pretty neat. Jupiter also has auroras, which are colorful light displays that occur in the planet's atmosphere. They're caused by charged particles from the solar wind interacting with Jupiter's magnetic field. Just like on Earth, they can be seen near the poles of the planet. But these auroras are much brighter and more intense than ours. We can even see this crazy light show from space. And now, we were finally able to capture this dazzling sight. JWST's photo shows the auroras of Jupiter, its rings, and even 2 moons, Amalthea and Adrastea. It's amazing how bright and clear they are on this photo. The Cartwheel Galaxy. NASA released this image on August 2nd. This photo shows us the Cartwheel Galaxy and its companions. The Cartwheel Galaxy gets its name from its shape. It kind of looks like a cartwheel, doesn't it? This is a giant, swirling mass of stars, gas, and dust, which is located in the depths of space. It's shaped like a pinwheel with long spiral arms. These arms are held together by the gravity of the central region, which is home to a supermassive black hole. But the Cartwheel Galaxy is a bit different from its spiral relatives. It has formed when a smaller galaxy collided with a larger one, creating a shockwave that rippled through the gas and dust. We'll definitely have to visit this galaxy someday. It's sure to be a wild ride. Spiral Galaxy M74. And here comes another spiral galaxy. NASA released this image on July 22nd. JWST had to peer through thick layers of dust and gas to see this beautiful star cluster. M74 belongs to a special class of spiral galaxies known as the Grand Design Galaxy. This means that its spiral arms are noticeable and clearly outlined. All sorts of amazing things are happening inside of spiral galaxies. Supernovas, stars being born in clouds of gas and dust, and many other cosmic wonders. The glowing gas and dust, the bright stars, and the swirling patterns of the spiral arms make them some of the most striking objects in the universe. Well, we can clearly see it on the example of M74. The Tarantula Nebula. This image of the nebula with a creepy name Tarantula was published on September 6th. The photo covers as much as 340 light-years across. This is a huge distance. Thanks to this image, astronomers have discovered new young stars that were previously shrouded in dust. The Tarantula Nebula is located 160,000 light-years away from us, in the Large Magellanic Cloud. It's the largest and brightest star-forming region in the local group, the galaxies nearest our Milky Way. It's named after its shape, which looks like a bit like the legs of a big tarantula. It's a vast region of space, about 1,000 light-years across, and it's home to some of the most massive and luminous stars in the universe. One of the reasons why the Tarantula Nebula is interesting to scientists is its composition. Its composition is close to the region of stars of the cosmic noon, the so-called state of our universe when it was only a few billion years old. At that time, star formation was at its peak. Thanks to the Webb telescope, we can study this galaxy better and find out what our universe was like at its peak. Neptune's rings. This photo was published on September 21st, 2022. In this photo, we can even see 6 small moons next to the planet, with Triton shining brightly in the upper left corner. You didn't think it was the sun, did you? And yep, Neptune has rings too. They're like the ultimate cosmic accessory. They add a touch of glamour and style to the planet. But unlike some earthly bling, these rings are made of small particles of dust, rather than diamonds and gold. There are 5 known rings around Neptune: the Gall, Leverrier, Lassell, Arago, and Adam's rings. Scientists think that these are relatively young, much younger than our solar system, and much younger than, for example, Uranus's rings. They were probably created when one of Neptune's inner moons got too close to the planet and was torn apart by gravity. We haven't seen Neptune's rings so brightly since Voyager 2 flew past it back in 1989. So this is a great opportunity to take a closer look at these rings. The Pillars of Creation. This photo was published on October 19th. The Pillars of Creation became famous thanks to the Hubble telescope, but this photo is very lush and much more detailed. These columns, located in the Eagle Nebula, are about 5 light-years tall, which is really, really long. And they look like some majestic rock formations, only much more transparent. Just like a typical Hollywood movie set, they're full of action and special effects. They're home to some of the most dramatic processes in the universe. The gas and dust are collapsing under their own gravity, forming clumps that will eventually become stars. The place is full of intense radiation, jets of high-energy particles, and supernovae. It's like a cosmic version of Survivor. And if this wasn't creepy enough, here's another photo published by NASA on October 19th. They shared it right before Halloween. Here, the pillars resemble an eerie hand reaching for something. Brrr. Anyway, all these photos give us a truly awe-inspiring sight. They remind us of the incredible complexity of the universe and the amazing things that are happening even in the darkest and most remote corners of the cosmos. Let's hope that the James Webb Telescope will continue to amaze us in the future. It's dark and incredibly cold. There's no oxygen. There's no water. There's no life. But the James Webb Space Telescope doesn't seem bothered by all this. Its main goal is to find the very first galaxies that formed billions of years ago in the early universe and observe the stars making up distant planetary systems. Its mission is to... But wait, what is that? The James Webb Space Telescope has discovered something absolutely amazing. A star-planet hybrid with very strange clouds. This bizarre world called VHS 1256b is actually a brown dwarf. Those are bigger than planets, but too small to classify as stars. They emit some light of their own and are quite hot, but their mass is simply not enough to fuse hydrogen into helium, like full-fledged stars do. Space bodies of this kind aren't actually brown. They occur in a wide variety of colors, but those are mostly invisible to the human eye. What we can see is the light they emit, and to us it appears to be dark orange or magenta. The brown dwarf we're talking about is almost 20 times the size of Jupiter. It orbits 2 red dwarf stars. And to complete one orbit, the brown dwarf needs 17,000 years. In fact, astronomers found out about this unusual exoplanet in 2016. But at that time, they didn't classify it as a brown dwarf. and thus couldn't explain its puzzling reddish glow. Now, thanks to the James Webb Telescope, they know the space object's origin. Anyway, back to those clouds. As you know, clouds on Earth are made of water vapor, but those on the brown dwarf are different. They seem to be made of sand. It looks like good old sand from Earth, but it's actually not. The clouds are made of tiny particles of silicate. Scientists have been putting forward theories about the existence of such sand clouds on exoplanets for quite some time. But the discovery the James Webb Space Telescope made is the first real proof. The silicate particles on the sandy dwarf are most likely quartz or some other mineral. In size, they're less than a micron, and 1 micron is 1/25th of a thousandth of an inch. In other words, they look like particles in smog. The exoplanet seems to have an atmosphere which contains some water, methane, and other substances and minerals. Interestingly, this atmosphere isn't still. It's constantly undergoing extreme changes. Another cool thing about it, scientists have detected carbon dioxide. And this is only the second confirmed discovery of this gas on a planet outside the solar system. By the way, the James Webb Space Telescope, with the help of which astronomers discovered our sandy brown dwarf, is an absolutely stunning piece of equipment. Around 100 times more powerful than Hubble. Even though the telescope itself is 3 stories high and its size equals that of a tennis court, its mirrors are the lightest large telescope mirrors of all time. When all the 18 mirrors of the telescope were completed during the manufacturing process, their mass was reduced by 92% in comparison to the initial discs. Each mirror weighed a mere 44 pounds. The telescope's mirrors seem to be gold, but in reality, they're made of beryllium, steel gray, lightweight, and brittle metal. There is indeed a gold coating on each mirror, but they can't be produced entirely out of gold since this material tends to expand and contract even with small temperature changes. That's why the total amount of gold in the James Webb Space Telescope is less than 2 ounces. James Webb's telescope side is cooling itself down, and its temperature doesn't rise higher than -370 degrees Fahrenheit. That's cool enough to make liquid nitrogen. A truly enormous 5-layered sunshield stretches around the telescope and reflects away as much sunlight as possible, letting the telescope stay cool. The telescope was launched near the equator because Earth spins a bit faster there, and this gave the rocket some extra push. The telescope orbits the Sun more than 1 million miles away from Earth, and when it runs out of fuel, it'll keep orbiting the Sun indefinitely. On the other hand, even though the telescope wasn't actually designed to be serviced or upgraded, it might potentially be refueled with the help of robots. This would extend its life. Anyway, if you think that our newly founded brown dwarf is the only bizarre exoplanet out there, let me show you some other breathtaking worlds. There is an exoplanet that is really something else. Just look at its awesome magenta color. You can find it in the Virgo constellation. The planet is called Gliese 504b. It orbits very far from its parent star, 9 times the distance between the Sun and Jupiter. The planet formed relatively recently and is still glowing with heat. That's why its surface looks pinkish. One of the oldest exoplanets we know about is about 12.7 billion years old. It's almost 3 times as old as Earth. This also means that the so-called Genesis planet formed only about 1 billion years after the Big Bang. The planet is so old that its 2 parent stars have had enough time to evolve into a white star and a pulsar, making almost 100 revolutions per second. I bet sunrises on this planet must look awesome. just 20 light-years away from the Sun, which isn't such a great distance when we talk about space. A bizarre rogue planet is roaming the Milky Way galaxy. But even though this planet doesn't orbit any star, it still has an incredibly powerful magnetic field. It's 4 million times stronger than Earth's. The exoplanet also produces amazing auroras. That's why when it was discovered in 2016, astronomers were almost sure they had detected a brown dwarf. But later, scientists got some proof that this space object wasn't big enough to be a brown dwarf. The planet sure is a mammoth among its peers. It's 1.2 times as wide as the largest planet in the solar system, Jupiter, and more than 12 times as heavy. Astronomers think the exceptionally strong magnetic field helps the planet produce auroras. But the most curious thing is that they're generated in a different way than auroras on Earth. It might be because the exoplanet's moon helps the planet create mesmerizing light shows. The next exoplanet isn't like any other. It's often called Super Saturn or Saturn on steroids. That's because J1407b has a colossal system of rings. They're 640 times as large as those our Saturn has. This bizarre world is the only planet we know about that has rings similar to Saturn's. If you move this giant to our solar system and used it to replace Saturn, its rings would look many times larger than a full moon. An exoplanet called WASP-12b munches on the light coming from its star. It's one of the darkest worlds people know about. All because its day side consumes light rather than reflects it back into space. The egg-shaped planet is giant, twice the size of Jupiter, and it traps more than 94% of the light that reaches its atmosphere. It might be the main reason for the temperatures on the surface of the planet that can rise up to 4,600 degrees Fahrenheit. The night side of the planet isn't as hot as its day side, a mere 2,200 degrees Fahrenheit. The difference in temperature makes water vapor and clouds gather above the surface of the planet. And from time to time, swirls of material from the planet's superheated atmosphere spills onto its star. What a view! Discovered in 2017, KELT-9b is one of the hottest exoplanets we know of. The temperatures there can reach 7,800 degrees Fahrenheit. For comparison, the temperatures at the surface of the Sun reach 10,000 degrees Fahrenheit. The planet is probably so insanely hot because it orbits extremely close to its star, KELT-9, which is way hotter and bigger than our Sun. Experts believe that the giant star might one day evaporate the entire planet.
Wow, the James Webb Telescope has been fully deployed. If you're interested in astronomy or space, you've got to be excited about the James Webb Space Telescope. Here's why. For starters, it's huge. How huge? The primary mirror of the JWST is over 21 feet wide. The Hubble Space Telescope, the previous largest eye in space, has a mirror of about 7 feet 10.5 inches. By comparison, if you place the two telescopes side by side, it'd be like putting a horse next to an elephant, and elephants are enormous. There's a perfect reason why the Webb, as it's affectionately called, is massive. It has to be huge because it's not an optical telescope in the traditional sense that most telescopes are. The JWST is an infrared telescope. It sees heat. Infrared light has a longer wavelength than visible light, so it needs a larger mirror to focus that light. So what do we have here with the James Webb Space Telescope? We have two never-before things going on. We have incredible technology and incredible science missions. Both the missions and the technology are out of this world cutting edge. The Webb is a classic example of engineering in the service of science. Because of its greater light-gathering power, the James Webb Space Telescope will be able to take images of things that we were never able to see before, but have always wanted to see. Things like exoplanets, and the first galaxies in the universe, and stars and planets forming inside nebulae. And you can bet that there will be plenty of surprises too. The James Webb Space Telescope has several technological tricks up its sleeve, which promise to provide its greatest scientific discoveries. The Webb has a coronagraph, and a very special coronagraph at that. The coronagraph is the tool that will allow the first real pictures of exoplanets. The coronagraph blocks out the bright pinpoint light of stars, which we already know have planets orbiting around them. Without the coronagraph, the starlight would make things too bright to see these planets, because planets are hundreds of thousands of times dimmer than the star. But with the coronagraph blocking the starlight, the exoplanets come into view. And the JWST coronagraph can block the light from up to 100 stars at once. We can expect a swarm of exoplanets. This brings us to the next high-tech gadget the JWST has up its sleeve, a no-slit spectrograph. Usually, an ordinary spectrograph will have a slit to allow a sliver of light to enter and be diffracted. Diffraction is the scattering of light to reveal the spectrum of the light's component wavelengths. But the James Webb Space Telescope's work is so sensitive that a sliver of light would overwhelm the optics. So a no-slit spectrograph was installed. The starlight gathered from the big mirror is sent into a fiber optic cable to send only a single spot of light into the spectroscope. And that's where the grism takes over. Sir Isaac Newton used a prism to discover the spectrum of sunlight, Roy G. Biv, as you may recall. But the Webb uses a grism. That's a compound word, like smog, which is smoke and fog. A grism is a graded prism. That means it has itsy-bitsy, teeny-tiny grooves that diffract the spot of light the big mirror sends down the fiber optic cable and into the spectrograph. The science of reading a spectrum of light is called spectroscopy. By analyzing the spectra of light from the exoplanets, the JWST will determine what gases are in the planet's atmospheres, as well as their density and even their temperature. It's an incredible advance in our knowledge. We'll be able to tell if a planet has oxygen or nitrogen, or methane, and other gases that may or may not indicate that the planet is habitable. Another Earth, perhaps. Presently, the JWST is parked in its permanent location. Unlike the Hubble Space Telescope, which orbits the Earth, the James Webb Space Telescope orbits the Sun. It orbits the Sun at one of the gravitational balance points between the Earth-Sun system. It just stays there without having to use much or any fuel to hold its position. So, as the Earth orbits the Sun, the James Webb remains parked at a spot that is also orbiting the Sun. There are 5 gravitational balance points between the Earth and Sun. They are called Lagrange points, after their discoverer, Joseph Louis Lagrange, in the 18th century. The Webb is parked at L2, the second of the 5 Lagrange points, which lies 932,000 miles out into space, way beyond the Moon. All this to observe a spot of infrared light. But first, the engineers must get, or acquire, that spot of light. To get a spot of infrared light, the 18 hexagonal mirrors had to be unfolded from their position inside the Ariane rocket that sent the Webb into space. Once the mirrors have unfolded, their positions must be adjusted to microscopic level accuracy so that all 18 mirrors produce a single image. Several tiny motors are attached to each mirror segment to make these adjustments. These motors, which must be activated individually, will gradually pull the honeycomb-like mirror segments into alignment. It's a critical part of the mission and takes months to complete. To align the mirrors to produce a single spot of light, the James Webb Space Telescope can't be jiggling around. The telescope must be kept absolutely motionless, and that requires 2 other cutting-edge technologies, the Sunshield and the cryocooler. In space, direct sunlight is very hot, and shadow is very cold. Therefore, the James Webb Space Telescope brought along its own high-tech Sunshield. It's huge, too, as big as a tennis court huge, comprised of 5 individual layers of Kapton film, only a millimeter thick. Each layer of the Sunshield has to be remotely deployed individually using a system of 8 motors and 139 actuators with thousands of parts. The purpose of the Sunshield is to help the JWST stay cold. The colder the better. And colder is what the cryocooler is for. Temperature can be measured 3 different ways: in degrees Fahrenheit, where water freezes at 32 degrees and boils at 212; in degrees Celsius, where water freezes at 0 degrees and boils at 100 degrees. But neither of these thermometers have a starting point. So, Lord Kelvin, in the 19th century, devised a third temperature scale, the Kelvin scale, which starts at absolute zero, the coldest temperature possible. The onboard cryocooler will cool the JWST to just 7 degrees Kelvin, 7 degrees above absolute zero. At this temperature, virtually all heat from motors is removed, and the telescope will be able to focus the light to a point without any noise, basically any motion interfering with the quality of the image. Finally, after all this incredible technology functions remotely as planned, we are almost ready to observe the infrared images from the giant multi-segmented mirror of the James Webb Space Telescope. Almost ready. A telescope can collect all the light it wants, but in the end, it must also be able to detect what it's collected. If the light is not detected, it's not truly observed. Enter the pièce de résistance, the infrared detectors. The Webb has 15 of them. The specially fabricated semiconductor material produces a slight electrical charge when struck by a photon of infrared light. The Webb's infrared detectors can produce a 1,000,000-pixel high-def image. A few of the detectors can produce a 4,000,000-pixel image. They must be durable enough to last 10 to 20 years without warping or corrupting, all while working at 7 degrees above absolute zero. In themselves, the infrared detectors on the JWST are an engineering marvel. But what are they going to take pictures of? The missions of the JWST. Well, they're cutting edge too. 70 of the first 280 target observations are exoplanets. Is there another Earth? Which exoplanets seem habitable? The Webb telescope will provide detailed spectroscopic analysis of the atmospheres of thousands of known exoplanets. For the first time, we will see images of exoplanets as they appear in infrared light. Cosmology, the study of the universe, is perhaps the primary mission for the Webb. Galaxies receding away so fast that their light is stretched into the infrared will be a prime target for observation. Hundreds of hours of observations are necessary to collect the faint infrared light from these first galaxies formed after the Big Bang. The JWST will give us a picture of what the infant universe looked like. Astronomers will learn new information about the dark energy that is driving the expansion of the universe and what role, if any, black holes play in the formation of galaxies. Star formation in the Milky Way and nearby galaxies is also part of the mission of the James Webb. By imaging hundreds of solar systems forming around newborn stars, astronomers will establish a definite history of solar system development. Now fact will replace theory, and a big step forward will be taken in our understanding of space. The James Webb Space Telescope is a bold endeavor that will mark an epoch time in scientific history.
Right now, 4 tiny, Earth-like planets are chilling around one of the closest star systems to us. We're talking second closest. These little rocky worlds are each about 20 to 30% the mass of Earth. So not quite Earth 2.0, but still pretty solid. Will one of them become our new home one day? Well, all of them are pretty close, so future humans might actually visit them someday. Not like next year or anything, but we could potentially send missions there. Don't expect any extraterrestrial neighbors, though. Those planets probably aren't home to life, or at least not anything we'd recognize. Let's take a look at them. The planets are called Bernard B, C, D, and E. How creative, huh? The innermost has a mass of 26% of Earth. The second one is a bit bigger, with a mass of 30% of Earth. The third one has 4% more mass than the previous. And the outermost is... no, it's not the biggest. Actually, it's just a baby, with a mass of 19% of Earth. All the planets are likely rocky, like the inner planets of our solar system. They orbit their star very closely. That's why they only need a few days, under a week, to make a full circle. Now, what about that star these little guys are circling? It's called Bernard's star. Astronomers have always had a hunch there might be at least one planet orbiting it. First off, this star is super close, in cosmic terms, of course. Only the Alpha Centauri trio is closer to us. Bernard's star is just under 6 light-years away, which is basically next door. At the same time, it's not like our Sun, Barnard's star is a red dwarf, the most common kind of star out there. It's got only about 1/6 the mass of the Sun. But red dwarfs are a goldmine for learning about planets outside our solar system. And studying Barnard's star can help scientists figure out what planets around single stars, like our Sun or this red dwarf, are like. Or what kind of environments red dwarf planets might have. And most importantly, we might finally find the answer to this super important question. Could any of these places actually support life? For the longest time, scientists thought there might be a big Jupiter-like gas giant hanging out near Barnard's star. All because the star has a little wobble. It looks as if it shifts towards and away from Earth over time, so something might be tugging on it. Interestingly, it wasn't a giant planet doing the pulling. According to a study from March 2025, it's actually 4 smaller rocky planets, each about 4 times the mass of Mercury. One day, they ganged up and started tugging on the star together. These planets are incredibly close to their star, so close that they can whip around it in just a few days. Sadly, because of that, they might be way too hot for anything like life. Besides, since these 4 seem to explain all the star's movement, the researchers think there's probably nothing else orbiting the habitable zone. So, there's no Earth 2.0 orbiting around Barnard's star. Still, it's an awesome find, especially since this star is basically our cosmic neighbor. Plus, the system might not stay off limits forever. With nuclear fusion engines or light sails, futuristic propulsion systems that could make the trip way faster. We might probably go there one day. And then we'll finally figure out if these worlds are really lifeless and maybe even colonize them. Now, let's see how scientists found the star's hidden planets. Normally, astronomers spot exoplanets when they catch them crossing in front of their stars and blocking some light. But Barnard's star is tricky because, in our view, it's like we're looking from above the system, so its planets don't block the light in the usual way. That's why they call it the Great White Whale of planet hunting. To get around this, researchers used a super sensitive instrument called Maroon X attached to the Gemini North telescope on Hawaii's Mauna Kea volcano. Over 112 nights, spread out across 3 years, the telescope picked up tiny changes in the star's movement. These shifts let scientists figure out how many planets must be tugging on the star, as well as estimate their sizes. At first, they found 3 planets. But then they used another device, deliciously called Espresso, and located at the Very Large Telescope in Chile. And only after a shot of this Espresso did they find a 4th planet. By combining the data from both instruments, they were able to more or less confidently say their findings were solid, not just random glitches in the data. Even though red dwarfs, like Barnard's star, are the most common type of star in the universe, most are way too far for us to see planets around them easily. These new findings suggest that small rocky planets could be pretty common around these stars, and that's huge for future discoveries. Now, finding new exoplanets is cool and all, but it might be even more exciting to dwell on their birth and evolution. And a recent study has made the sweetest discovery ever. Newly born exoplanets might actually look like Smarties, that popular British candy, rather than spheres. We've always kinda assumed that baby planets are born ball-shaped, but they might be oblate spheroids instead. A team of scientists from the University of Central Lancashire in England used computer simulations to build a model of the formation of planets in dense gas disks surrounding young stars. After that, they compared these models with actual observations and noticed that the young planets took pretty unusual shapes. The thing is that even though almost 6,000 exoplanets have been discovered so far, astronomers still don't have a clear understanding of the sequence of events marking their birth and early evolution. But this new research might finally shed light on this process. So, the astronomers examined the formation mechanisms of gas giant planets like Jupiter and came to the conclusion that planets built up from their centers. After that, the researchers focused on the initial shapes of such planets. They were also interested in how they could encourage the growth of these planetary seeds. How could they turn into such massive planets, some of them bigger than our solar system's largest giants? According to the standard theory of the formation of planets, such growth happens gradually and smoothly. First, dust particles start to stick together, turning into larger and larger objects. This process lasts for a very long time and is known as core accretion. It's the model of planet formation scientists favor. There's another theory, according to which planets' birth might happen over shorter periods of time. This data involves a protoplanetary disk, a disk of gas which makes up 99% of its mass, and dust, around 1%. This disk orbits a newly formed star, and hypothetically, planets might form from this cloud. Protoplanetary disks are likely to be common byproducts of star formation. They might range in mass from 0.001 to 0.3 solar masses. Inside such disks, matter slowly moves inward, and dust particles grow bigger, to the size of pebbles. At one point, after 2 to 3 million years, a giant rotating protoplanetary disk breaks into pieces, and that's how baby planets are born. This theory is known as the disk instability model. As for the model built by the team, it seems to support this second, less favored theory: rapid planet formation through disk instability. All because this theory explains how large planets can form relatively quickly at pretty large distances from their host stars. As for the weird flattened shape of these newly formed planets, it might be due to the material falling onto them. Most likely, it goes mainly to the poles of new planets. One of the main conclusions of the research is that the appearance of young exoplanets, as we see them from Earth, may vary depending on how they're angled. If Earth is directed face on to an exoplanet, it will seem that the latter has a traditional spherical shape. But if seen on edge, a baby exoplanet will look like a real Smarty. The team is going to continue to investigate the formation of planets with the help of an improved computer model. They believe they can find out the role the environment around a young planet plays in affecting its shape and formation.
Very recently, astronomers have found 3 potential super-Earth planets orbiting a somewhat close orange dwarf star. The term super-Earth is used to describe a planet beyond the solar system with a mass higher than that of Earth but below those of the ice giants of the solar system, Uranus and Neptune. An international team of researchers, led by Dr. Shweta Dalal from the University of Exeter, found that the exoplanets were orbiting star HD 48498, which is located around 55 light-years away from Earth. The planets travel around their star in 7, 38, and 151 Earth days, respectively. The study describing these findings appeared in the journal MinRes on the 24th of June 2024. The coolest thing here is that the outermost exoplanet candidate orbits in the habitable zone of its host star, and the conditions there might be comfortable enough for liquid water to exist on the surface without boiling or freezing. Such habitable regions around stars are also known as the Goldilocks zone and are believed to be ideal for potentially supporting life. Another reason this discovery is so important is that the orange host star is like our Sun. But since it's an orange dwarf, it produces less radiation than our yellow dwarf star. It's also the closest planetary system to host a super-Earth in the habitable zone of a Sun-like star, which makes this discovery super exciting. It can help us move forward in our quest to locate habitable planets around solar-type stars. Who knows? Maybe this planet will be our new home one day. These potential super-Earths were detected thanks to the HARPS and Rocky Planet Search Program. Throughout a decade, the team taking part in this research has collected nearly 190 high-precision measurements using special equipment. By analyzing the spectrum of light coming from a star, astronomers can figure out whether it's moving toward us, this is known as blue shift, or away from us, that's what we call red shift. And still, to make sure their findings were correct, the team used lots of different methods and comparative analysis. Everything confirmed their conclusions, There indeed are 3 planetary candidates with minimum masses ranging from 5 to 11 times the mass of our home planet. The team also believes that the proximity of the star, together with the outermost planet's favorable orbit, can make this system a great target for future studies. Hopefully, further research will open doors for our understanding of planetary systems and the potential of life outside our solar system. Scientists have already discovered more than 5,000 exoplanets, which are planets outside the solar system, since the first such world was confirmed orbiting a Sun-like star in 1995. To find those distant planets, astronomers use different equipment, like NASA's Kepler Space Telescope, launched in 2009. Its mission was to find as many Earth-like planets dwelling in the Milky Way galaxy as possible. But it's not the only instrument used for searching exoplanets. Anyway, now let's look at the most exciting and promising of these worlds. Gliese 667 cc is a mere 22 light-years from Earth. But even though it seems close, it's still around 129 trillion miles away from us. The planet itself is around 3.8 times as massive as Earth and completes one orbit around its host star within 28 days. In other words, a year on that Earth-like planet is 13 times shorter than a year on our planet. Luckily, the star is a cool red dwarf, so the exoplanet most likely lies in its habitable zone. But there's still a chance that this world might be regularly baked by the flares coming from its parent star, which is not cool on many different levels. Kepler 22b is way further away than the previous world, more than 600 light-years away from our planet. It was the very first Kepler planet found in the habitable zone of its star. This world is larger than Earth. It's about 2.4 times our planet size. Sadly, we still don't know whether this planet is rocky, liquid, or gaseous. The orbit of Kepler 22b is similar to Earth's. It takes the planet 290 days to orbit its G-class star, which is kind of like our Sun. But this star is smaller and colder than ours. Another Kepler planet, this time it's Kepler 69c. It lies a whopping 2,700 light-years away from us. This world is also almost 70% larger than Earth. Researchers know nothing about its composition, but they found out that the planet needs 240 days to complete one orbit. This makes its position in its system like that of Venus in our solar system. At the same time, this world might be more habitable than Venus since its host star is a bit less luminous, 80% of our Sun. TOI 733b is a recently discovered world. It was found in 2023. It's out there, 245 light-years away from Earth, and needs just 4.9 Earth days to complete an orbit around its star. But the coolest thing about this planet is that it might have a massive ocean. According to scientists, the planet is likely to be completely covered with water. Does that mean there could be life on this super-Earth? Time will tell. GJ 1214b is located 48 light-years from Earth. This planet is a super-Earth, almost 3 times bigger in diameter and 8 times heavier than our home. It orbits around its red dwarf star faster than you can binge-watch your favorite series, finishing a complete loop every 38 hours. But it's not just the planet's size or orbit that's out of this world. It's pretty hot out there, with mind-melting 450 degrees Fahrenheit. But the coolest thing is that this planet is practically drowning in water. The sizzling temperatures and crazy high pressures on JG 1214b create some cool materials like hot ice and superfluid water. Superfluidity is something that happens in liquid helium when it's almost as cold as it can get. On Earth, water totally missed the memo about being superfluid because it needs ridiculously low temperatures and off-the-chart pressures to pull off that trick. Still, there's not much use in superfluid water. Even if you try it, you'll just get dehydrated. The super-Earth that's closest to us was discovered in 2016, and it's called Proxima Centauri b. It's located a mere 4 light-years away from Earth and has a mass remarkably similar to that of our planet. A year on Proxima Centauri b is short. It only takes the planet 11.2 days to complete a circle around its central star. Scientists discovered this world after they noticed that its parent star was slightly wobbling. They hadn't been sure what exactly had been happening there until they realized Proxima Centauri b's gravity probably produced pulls and tugs that caused these wobbles. Although the exoplanet is traveling in the habitable zone of its star, Proxima Centauri, it is exposed to extreme ultraviolet radiation, all because it lies very close to its parent star. Also, none of the telescopes that are currently working and exploring exoplanets are positioned well enough to capture the light from the atmosphere of this super-Earth. Most things there are still a mystery to us, even though we're talking about a planet that's really close. Super-Earth TOI 715b orbits a red dwarf, a star smaller and cooler than our Sun. At the moment, such stars remain prime candidates for finding habitable planets orbiting them. Those miniature rocky worlds have far closer orbits than those circling around stars like our Sun. But since red dwarfs are small and cool, the planets don't risk anything when crowding closer. They're still safely within a star's habitable zone. Experts say that TOI 715b might have once had an atmosphere thicker than that of Neptune, and now the planet could be in a transition state where it's losing its atmosphere. To confirm this suspicion, scientists need to do more research, and they might finally learn whether this planet is a watery terrestrial planet.